Oh, yo, what's up, everybody? Welcome back. Today we are working on beefing up our barcode scanning neural network. We've been on this saga for a little bit of trying to scan barcodes on my phone. We will not go into details as to why, but like it would be like a kind of a fun project. Now, you might say this is very simple. Barcode scanners have been around forever, and I would say that they barcode scanners that are in stores, they have lasers on their phone, lasers that like control lighting conditions and stuff. We are trying to scan something with like my shitty phone on my camera. You might say lots of people have done this before, and I would say you are right, but I don't know what they did and I didn't look it up. Right? We tried to do some barcode scanning by hand, but I think like the signal processing techniques that you would need to use to get something that is like robust is actually kind of difficult, right? The one I always jump to is this like egg carton. I think that this is just a hard thing to scan. In fact, the scanners at the store often miss this one, and I have to like take out this like gun scanner from the self-checkout and like scan it manually, and that gun scanner is like not using like the one-dimensional scans. I think that it's doing something optical because it shines like two blue lights, and I don't know what it could be doing if not like using those for you to position where like the optical scanner is supposed to go, and so then it's doing something intelligent inside, right? Now, I'm sure that there's like an intelligent thing you could do by hand, right? But we are too stupid to figure out what that is, and so instead we're building a neural network training framework to build a neural network that will learn to find the right things, right? And so that brings us to today. We have, a first pass at like an app that does scanning, right? So we have kind of like, we generate this high res-ish image. This is like 1024 by 1024. We take some like random picture, we generate some like perfect-ish barcode, and we like slap it on top. We like bring this thing down to low resolution and run our like stage 1 neural network on here that says like, find me where this thing is. It's not doing a very good job right now. I can get better, etc., but like this is a box it predicts. We like extract that box from the high resolution thing, and we run a second neural network that is supposed to predict basically he's trying to predict like 1 or 0 for each module, right? So he's supposed to predict 1 0 1 0 1 1 1 0 1 1 0 1 0 0 0 1 1 type shit, right? That's kind of like what this thing is supposed to do, and so we have like an example of it doing that, and like we checked the output here the other day, and it's like basically right. But a lot of what we have trained right now is we have only shown the network like a perfect world with perfect barcodes, and there's a lot of like failure cases that I'm worried about. That we need to make it so that it handles it correctly, right? So the end goal here is that I have like a video stream on my phone, and I'm like taking like a code and I'm putting it in frame, right? So one thing we have to worry about is, what if the barcode is half in frame? That's something that like our neural network has like never seen before. What if in the second stage we like give it a barcode that's like 90 degrees rotated by mistake because like our stage 1 detector did like a bad job? We can't do that because like the second stage would just fall the fuck over, and so we need to like reject bad boxes. We need to do things like right here, we found when we like set this up the other day that like we have to show it both the right side up and upside down image. And one of those will be right, but one of those will be like really wrong, right? And I think it's because if you watch kind of like the output, I haven't confirmed this, but if you watch like the output of this thing during training, when we try to train stage 2, hold on. Yeah, I think that's how you run this. It like learns like extremely quickly, like it learns extremely quickly that there are like common patterns that are always true, right? So like here, it learns that there's always a section of black, white, black, white, black, white. And here it learns that there's always like white, black, always here, white, black, always here, white, black, right? And you can tell like what that means is that it's not even fucking looking at the picture for those, which means that like it's probably learning some stuff, right? So we need to do things like make sure that it's seeing like invalid barcodes. We might want to do things like check that the outsides of the barcodes are like correct, right? There's all sorts of things that we want to do there. So today's goal is just trying to like make it so that it sees more things that it's likely to see in real life. Not perfect, right? Because our data is obviously not representative of the real world right now because it's just like hand-drawn lines on a piece of paper, but it's like somewhere to start. So that's the plan. I have like some things that I want to do. I think the goal is going to be that we set this stuff up so that it is what we are doing right now is still possible, and that way we can like run a bunch of experiments overnight and like compare the outputs after and just kind of see how fucked up everything gets. Right, so like maybe by adding in like a prediction that says how confident am I that the box is in frame, or even just by adding data that sometimes where there's a barcode that's not in frame, that could just like fuck up everything. And so like we should have like a baseline case that we can like test everything against. So yeah, I think I have some stuff that I want to fix, and I'll just kind of like explain probably what these things are supposed to fix as we go. So thing 1, reject out of frame codes. So I think, as I bring the camera over a barcode, we're going to start with, a world where we're just looking at like stuff. There's just like stuff in frame. And so we need to make sure that we don't try to scan that. We'll also have the case where like we are slowly getting into frame, right? So the barcode's like half in, half out. And then we will also have the case where the bar is fully in frame. And we need to make sure that we like identify these cases. So I think this is like a bar visible training target is what I'm thinking. Which means that our data sometimes has to create out of frame barcodes or just like fully missing barcodes. Either like we might have like a random probability for no barcode at all. That's like maybe like 10% of times there's just nothing. And then we also will have one for if it's in frame, and I guess those can share the same thing, right? Fully in frame, I guess is the thing that we want to train. So what does that mean? I guess we'll start at data generation. I think that makes sense. So we kind of just like generate this data on the fly because it's easier for now. Eventually we will probably mix in real data, but for now, generate on the fly. And in here somewhere we have like barcode gen. And I guess he exports like training labels right now. So he says like, here is a list of things that I want you to predict as like one of his outputs. So I guess we kind of just will put like a fully in frame thing there. And like we said before, we want this to be configurable at runtime so that we can check both, so we can like compare. So I guess we are going to have like a parameter in here that's like, when we are making bars, he has like labels that comes out of this thing right now. It's bounding boxes is what we call this. This is going to turn into, I guess, kind of more like box labels. Box labels, I think is a better word for this, because it is now going to have more than just the bounding box in him. He's going to have the bounding box. This is X, Y. It's actually square root width and square root height. And then this is rotation X, rotation Y. And then we are going to add a thing here that is fully in frame. Right? That's kind of what we want here. And so that means that this is going to output 7 things here. Anonymous, thank you for the tier 1. Much appreciated. Can we also generate blurred barcodes? Yeah, that's one of the things we do is we have like a blur param on the barcode to say like how blurry do we want to make it. We don't blur the backgrounds yet though, but we should probably do that as well. We also want to do things like add noise and stuff, but that's later. That's later. Okay. So this guy wants to say, am I fully in frame? Easy. So this is on instance random parameters is where this stuff is coming from, which I think we can do right now. So we're saying like on GPU, we know that we have like 1,000 boxes to make. What are the parameters of each of those boxes? Like their width and height and shit. And so I guess we just go to sample params kernel and we adjust whatever the fuck he does, which comes from generate CL sample barcode params. So here we have changed the format of B box out. So this is going to be box labels now. Labels out, I guess. Box labels out, I guess, maybe is a better name. And here we need the 6th thing here to be, first of all, this is now 7 wide. And the last piece here is fully in frame. Easy. And so how do we predict this? I guess we look at our x-axis and y-axis. Do we have that? We have the box x-axis, which is cos rot sine rot. Easy. Easy. Which we can use here. We have the box y-axis, which is just like a 90-degree rotation of this, which I think is negative sine rot and cos rot. Or as we can do instead, we can do box x-axis 1, box x-axis 0. Okay. I'd add as a background image something like stripes that might be picked up as a bad conf kernel. Yeah, it's not a bad idea. Like a wall, like a stripy wallpaper, or like some pictures of zebras and shit. I don't know if I like really want. I kind of want the network to stay simple though, and so I would be willing to say that a background that's stripy is just like out of scope. I would be willing to say that. And like just don't fucking try to trick it, because I would rather have it run fast than handle that case, and I think that's a hard case to handle. What color scheme theme do you use? It's Sonic-Eye in NeoVim in Alacrity with term GUI colors off. It's supposed to look like this. It's supposed to look like this, but I don't know how I ended up in this state. But this is where we ended up. Okay. Cool. So here we have the X and Y, and so I guess we like look at the four corners of our box. So we look at like so we have like top left here is box x-axis times x scale over 2, probably. I don't know like what unit x scale is in here. What is this? I think this is relative to width of the image. Yeah. And y scale is relative to height, which is confusing. I think, honestly, this should also be relative to width. I think that solves a lot of problems. Yeah. Yeah. Which, right now, width and height are always the same right now, so it doesn't matter. But I think that's a thing that I've had in my head for a bit. So this is, do we have width and height here? Do we know that? Image width and image height. We do have that stuff here. Okay, cool. So we can like multiply this image height or image width here. Hello? Image width here. Okay, so this is gonna be like the center, which is... Oh wait, but everything is in normalized space. So wait, maybe it's fine to just not do that. Yeah, so we have like center is x offs over this. Just going off what I have written below. And so it looks like these are normalized to the image width and image height. So, okay. I feel like everything being normalized to image width might make everything easier. But whatever. Okay, so we have like center plus x scale. So our x scale is how wide this thing is over 2. Yeah, sure. So we have like float, and this is a normalized space, plus box y axis times y scale over 2. And I guess we want to know... There's like some aspect shit in here, but everything's square for now, so I just won't worry about it. Yeah, it's fine. So we have top left, top right, bottom left, and bottom right, which comes from, you know, I guess top left would be minus minus. Top right is plus minus, bottom left is minus plus, bottom right plus plus. Yeah, so anything left should be minus, anything right should be plus here, and anything top should be minus, everything bottom should be plus. Okay. Is CL like C for OpenCL? Yeah. I guess float 2 is something like B float. It's I don't know what B float is, but float 2 is like it's just a representation of two floats. It's a vector. Yeah, yeah, yeah. So then we can just say like fully in frame is going to be point in point between yeah, like point is normalized, maybe is something we could say here. That's like a generic function that would check if it's like 0 or 1. And then we can just do this. That sounds kind of right. Point is normalized, and we'll say float to point, and we'll just say like return point 0 is greater than or equal to 0, and point 0 is less than or equal to 1.0, and then we do this for 1 as well. There we go. That seems like it might be right. I think that there's like aspect non-square probably breaks this. We'll just put a note here for when I inevitably fix that in the future. Breaks in frame, check. And I guess what we can do is we can generate some images, and in image gen, I guess we probably want to check the box output. I guess let's start by just like running image gen and seeing if it's like fucking broken. Because it probably is. Yeah, there's probably a bunch of stuff that doesn't compile right now. So let's fix that first. Box labels. Box labels. Okay. That seemed okay. So now we have box labels here. And we are just rendering these things directly. So we need to be a little careful here. Where this is like from 0 to 6, probably. And then we want to update some label, probably, for like in frame, right? In frame is equal to res val 6. And that means that we need some sort of like in frame thing here. I don't know. Something like this. We only support float export from GPU land right now, so our boolean is just a float. That's kind of funny, whatever. This guy needs like in frame here. And here I guess we say like var in frame is false. Okay. So this guy needs to be I guess this guy's a pointer. Okay. And then we need to like display this in UI somewhere, right? So we want like a label where we put this probably like in frame label retriever, in frame is in frame, and then we like define a thing that we can put in the GUI that will like get that. So in frame label retriever is a structure who has a function get text on it, if I remember correctly. And this guy is going to be like, he's going to have some buffer here that he writes into. And he's going to have like in frame. Here is a pointer to a boolean. Great. And we're gonna be like, oopsies. So stood format buff print into buff. And we're gonna be like, in frame is this. Easy. And we need to count how many characters this is. This is 10 plus 5, 15. So we'll say 15 here. And if you go to fucking bounds, then we fucked up that count and we'll crash. All right. Let's see. Okay, so he's mad because the concrete params size. Oh, he's mad about. That's fine. Let's just take a warning. Here he's like, scalar operand has greater rank than type of vector element. Oh, so I forgot to put some Fs for floating point 32. Fucking hell. Is that better? Is that better? It's a little better. No space left in buff print here. So 20. Did I fuck that up? I might have. What is he fucking pissed about? I've like attempt to unwrap error, no space left. Am I fucking stupid? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh. Gotta dereference the pointer. Okay. So, bad news, in frame, always false. Always false. Which seems bad. Because center here is, it needs to be offset here. This needs to be plus 0.5 on both of these. Nothing's in frame because there's no camera. So true. Okay, so this is in frame. Okay, so it does seem like it is sometimes changing. So this being false is good. True, 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 false. That's correct. True, false, true, 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 true. Okay. I mean, I think this is right. Which is kind of sick. Yeah. I mean, just like eyeballing these, it looks... Did I see it flicker there? No, I didn't. Looks correct to me. It might be better to predict how in frame we are, but that will be fine. That'll be fine. Only the full width has to be in frame, right? Yeah, but I'd rather just wait till the whole code's in frame. Fuck it, you know? Doesn't really matter, right? Because, like, remember the final use case here is that, like, I am holding something and putting it in front of the camera. So if I'm okay with being like, you have to fucking put the thing in the field of view, right? If you don't do that, go fuck yourself. I'm like, okay with, you know? Okay. So I guess that means that we need a config that will turn this on and off, right? Because we said that we wanted to, like, choose. We wanted to be able to choose at runtime if we're trying to predict this thing, right? So we need this sample barcode params to have a parameter here that's like, that says like, predict in, or like label in frame. And so here we say like box stride here is like if label in frame is if label in frame, then 7, else 6. And then we use box stride everywhere we said this before. And then here we say, if label in frame, we do all of this stuff. But we might not if we don't do this stuff, right? Cool. So then we can go back to generate barcode gen here. And we're going to say that our output of the box labels, his size is going to depend on some input parameter, right? So here we're going to be like, here we're going to have label in frame like this. What is dims here? Num barcodes, I see. Sure. So we're going to say like, no, like labels, like box label per image size, box label size is if label in frame 7 else 6, this gets box label size here. And then down here, I think it was at the right before this, I think we said label in frame. Let's double check that. Yeah, after seed. Int from bool label in frame. Okay. Cool. So this has to make it up somewhere. So this is like instance random params label in frame, which is going to have, you know, label in frame here. Okay. This is in image gen, I guess we're gonna have self config label in frame here, which means this guy needs label in frame bool, which means this comes from data, I guess. This guy also needs stage 1 config data label in frame here, which doesn't exist yet because this is a different config. Okay, and hello? Oh, here we go. Where are we here? I assume that this also has label in frame here, which comes up like this. It was after train num images, right? Yeah. Are you planning to stream from your phone to your computer to do heavy stuff, or do it all on phone? All on phone in WebAssembly. All in phone, on phone in WebAssembly. User here, I think. We'll make it so that it doesn't think this is to be comp time. And then this stuff is mad because what? Yeah, that is supposed to be a bool. That's a good point. Good point. Then where did it go here? Generate training input, got it right before target. All right. This is one of those things where we should probably be taking a struct as a parameter input to this function now, because it's getting really easy to fuck this up, but whatever. Okay, so now I guess we should, if we add to like default config here, configs, what is it? It's like configs, default config. We want these guys to have label in frame to be false to preserve previous behavior, right? And what we should see is that if we run our old network now, if we just run like smelly with configs default bbox, if we run this thing now, it should work as before. But he's mad because a use of undeclared identifier at 686 in generate CL. Okay, because it was not 686. Right, I know where it is. It's here. He's mad because this is used here now. Okay. Okay, so this ideally would work, but he's mad because expected expression. Oh yeah. What the fuck? It's fucking not how fucking C works. Okay, so good news is that this is still working, the old mode, right? And so what I would expect to see now is if we say like mkdir experiments, we are going to copy config's default bounding box to experiments. And I guess we're going to say default bbox, this is 001 baseline. This is like what we want to start with, right? Then we're going to say we have 002 in frame, right? And we're just going to say that we enable label in frame here. And this is going to fuck up all sorts of shit probably, right? That's what I'm going to assume. So here we're like, can we run from experiments? Oopsies, experiments 002 in frame. And so I assume this is going to start falling the fuck over because it's going to be like, my dimensions are wrong. You're trying to predict something that's 6 wide, but we are getting something that's like 7 wide now. And so we should be able to be like in here somewhere. This in-frame thing, he basically just needs to change his final output size to say 7, I think. I think we can use like the exact same neural network, but just have 7 outputs at the end, and then I think everything should just kind of work. No, because we have invalid dims. Oh, because we have loss multipliers as well. So I think that in-frame contributes probably 1.0. We might want to change this to say like that thing is weighted. Actually, I think that we saw something similar in the YOLO V1 paper that we're taking inspiration from. I think they talked about this exact problem. So they said that they have like coordinate weighting, no object weighting. That's kind of what we want, right? So they have told us that they have this problem, and they have no object weighted at like 0.5 relative to 5 on the coordinate. So this is like 10 times less. So we'll weight this thing at 0.1 and kind of call it for now. And what we're hoping to see is that it like compiles and runs. Okay, so we're at like 609 here. He's mad because he's using a hard-coded 6 in here, and so now this should be config loss multipliers len. That solves that problem. This needs to be intcast from a u size to a u32. Cool. And so now we're getting down here that in the validation stats, he's like, I expected this shit to be 6 long. That's so true. Let's say that this is less than or equal to 7. These totals are going to come from 7s here. I guess... So we're like calculating like the error for every single parameter as part of our like validation statistics, which I think is like great. I think that's helpful. And so I think what we do here is we probably have to like switch this like if config data label in frame, we have like batch size or like num predictions is 7 else 6 like this, right? And we use this somehow, so this should be definitely equal to num predictions like this. This needs to be specifically labeled as a u32, or else it's trying to do that at comp time. Then here we need to be like, these things are 7 here, but this is num predictions here and here and here. And then I think what happens here is that our totals at 7 at the like last index and the sum squares will just stay at 0, which is great. And then We just need like to name that thing as you know, how wrong were we about in frame? I mean, that's not like, yeah, in frame. That's fine. It's not ideal, but it will work. It'll work. And so what we should see now is that if we run the original for a little bit, fuck. Something doesn't compile. Yeah. So true. So true. Where the fuck did our... Oh, ow, I can't read this. We really need to like refactor this a little bit. So loss CPU len over num predictions goes here and here. And here. Ow, ow, how, I can't read it. I can't read it. It looks like such shit. But I'm hoping that we see like correct statistics get generated here with the original config. So if we look at training output log, we should see in frame loss is always 0, which is good. So he's like writing this thing down, but the in frame loss is like not relevant, so it's just 0. It's not participating. And then if we start running with 002 config, which is with that on, we should see that in frame loss starts like contributing in some way. So we can see like if we look at the training output, log, we start to see in frame loss is a relevant participator in this thing, which is great. And so what we can also do with this information is we can immediately like run our tests. So we can say it's like for you know, config in, how do you do this in this language? Config for experiments star pi do for p in this. Is this how you do this? I forget. Do for p, there we go, and then we do like this comes from here. You just run that thing as the config. Out dir is in like experiments out base name p or something. Sure. Background dir is backgrounds 3, and then we need to like kill this shit after some amount of time. So we do like timeout like 30 seconds. So we run both of these for 30 seconds. They should go to some output. Python 3, no such file directory. I guess we need to be in the right environment for this. And we probably need to make dir experiments out or something as well. But we should be able to like look at both and make sure experiments out. We should be able to see that like we should see how this affects the quality of like training on the other parameters, if that makes sense. Oh, time exists as a command in bash or the next thing. I think it's just like a GNU utility, I think. So we should see after 30 seconds, this just like dies. How long has this been? 30 seconds is long. There we go. So that's experiment 1, then we run experiment 2, and then we can actually like look at the outputs of both of these and be like, did we fuck it up? Did we done fucked it, you know? Which is zig out bin train output viz on experiments out star log like this. Nice. Right, so we can see probably we'd expect total loss to be higher, right? But as long as like some of the other guys are still calculating okay, then it's okay, right? So we see that like the X position and Y positions are like chilling, width and height are chilling, but our rotation, like adding this parameter has made our rotation get worse. Probably because he is prioritizing learning about in frame before learning about this stuff, right? So this is good. We've got like lots of information here, and I can like use this to like, it's possible that like over time these like rotation losses would like come back down once it figures out how to do in frame first. So I might like leave this as is. We might run the experiments so we have like different loss multipliers on the rotation versus in frame and stuff. But this is great. This is great because this gives us like lots of we can easily compare that stuff later. Okay, so I think we probably do like a little zig format source and just make sure that like our unit tests are passing and shit. And we should be able to just be like add dash u get commit dash m whip. This should get committed as is almost. But this I need to do a review on this. So we'll say add prediction for if box is in frame. Ooh, wait, we're not done yet though, right? Because we also want our data on the stage 2, on like the second half of this thing, to sometimes like not put boxes at all. Right? That's kind of like the other part of this experiment. So we need in our like rand okay, the easiest, or sorry, generate. The easiest thing to do here is when we have like sample when we have sample barcode parameters here, the easiest thing to do is just huck in a like no code probability. Or maybe we just increase the width of the X and Y positions. It's like you kind of want most of them to be, you want a lot of stuff to show up in the middle, but like occasionally to be like really outside. And then occasionally to be like fully fucking gone, right? Those are kind of like the cases. So I think we probably increase the offset ranges here and just hope that we get enough that are in frame sometimes. And then I think that we throw in like an extra parameter that's like fully gone, like no code prob or something, right? And we like add that as something that we check here. So like no, like missing code, or like should render code is so we're gonna take a float between 0 and 1, and we're gonna check if this is less than the no code prob, right? So if the no code probability is like 10%, then this will generate a number less than 10, less than 0.1 around 10% of the time. And so we actually should render if this is greater than this, right? So that's like 90% of the time we would say we should render. Okay, cool. And then if we should not render the code, then we just like fuck everything up, right? We just say like x offs is equal to like image width times 1,000. Right? Just like fuck our shit up. Seems reasonable. Then this will just be like fully out of frame. And maybe we do this down here actually. So here, maybe we just go like if should render code, we do all of this. But otherwise, maybe we just like fucking memset everything to 0. You know, like maybe this just all gets zeros? Is that crazy? So this is definitely not in frame. But then we also just like say XY width height 0. Seems reasonable to me. Maybe we'll find out later that there's a better, like maybe we don't want to be doing this. But I think this is reasonable. So now we should be able to add in like this guy's expecting us to have a no code probability, which comes right above num images. Okay. Barcode gen. So his randomization programs has like no code prob as a single floating point number. Great. And this goes in our random parameter stuff right before num images. So no code prob comes from here. Great. And now all we should have to do is add that to our configs. No code prob. So our baseline says that these are 0, right? No code prob 0.0. Okay. And I guess that means that we should also have this like the baseline test here and 001 here. And in this in-frame test, we probably want this to be like 0. Maybe like 10% of images have no code. Seems reasonable to me. Seems reasonable to me. So now if we run image gen with like the default config, we should be chilling, except he's mad. Image gen 149. So we should say like if config data label in frame, then we have this guy, but otherwise we don't. Okay. So now we should be kind of chilling. I guess we should have in frame initialized to true by default, because that means that if we're not updating it, then he will say everything is in frame. So our default guy, every single one of these has a barcode, right? And we should be able to be like now, image gen with experiment, oopsies, experiments 002. And what we should see is sometimes the barcode is not fucking there. Okay, so one thing that we are seeing here is that it is like out of frame more, right? Which is good. And then every once in a while, about 10% of the time. Hold on. Oh yeah, we did. Experiments. This is, yeah, he has 10% here. So I'm concerned that it looks like this isn't doing what I want. Right? Oh. I see. He's said no bounding box, but he's still rendering the code. So we made a fucking mistake here. We're fucking idiots. So what we also need to do is, I guess, here we have like should render code here. So we say, hey, when you get around to actually generating the barcode, check that shit. And I think this stuff, whatever, everything else is 32-bit, so it doesn't matter where this goes. And then when we get into the part where we actually are fucking doing shit, generate barcode, this guy needs to say, basically just if our params should render code, if this is off, like, can we just like return? But that means that we need to like initialize this stuff, but that's fine. I think that as long as we do the sampling from the background first, the mask should stay 0 and should render should stay 0. So I think we're chilling. Let's try that. Let's try that. How do we zoom out? That's what I want. Okay, there. 16, fully gone. There we go, fully gone. You could argue that our like distance range is like a little too far, but I think it's fine. And so again, we can run I think what I want to do is I want to have in our experiments here, I think I want like in-frame prediction as one thing, right? One thing where we do exactly what we did before. But we just add the prediction for if we're in frame, right? Which will change something. Right? So we look at the baseline, we copy paste the randomization params. And then I want the third experiment to be like in frame, like missing, like more missing codes, right? That's kind of where I feel like this should be going. And this guy gets no code probability turned up, and the like random the XY randomization range is increased, right? So our baseline should be the same. I guess we'll remove it. And again, for this like timeout test, 30 seconds was too long. I'm more just looking for like sanity testing that like the stuff is outputting stuff, and then we can look at the results later. So let's do 15 seconds for each of our 3 experiments. Make sure that they're all, so baseline still loads fine. Great, still training something okay. Give him a few more seconds. Give him a few more seconds. He's gotta wait till 15. Okay, then we have the same data, exactly the same, but we are also predicting whether or not the thing is in frame. Great. And then, after this 15 seconds, we'll have sometimes the code is just fully fucking gone, so. Oh, that's interesting. You can actually see that he's, you could already tell that he was struggling more. Like the first few iterations, the blue prediction box was like struggling to just track at all. So that's kind of fun, right? So we can see here that orange is like the increased randomization. And if you compare like orange and green, already in like the first few iterations, like green has an easier time because he can just predict that I'm in more often, but then they start to track okay, right? And then, you know, we can like start looking at this. But that's good, that's good. All of these 3 configs are working. So I think reject out of frame codes, I think that is ready to go. Ready to go. So this is add no code probability. And I think this is a separate commit from the first thing, sure. Whip experiment. I guess this is just like, this is not really an experiment. This is just like a data generation configuration. Sometimes present no codes. Cool. Cool. Okay. So we want to reject bad predictions. So sometimes our box will be shit. But it turns out, according to this YOLO paper that we've been looking at, the network knows if it does a bad job. Right? Basically, like there's some like uncertainty that can happen that can make it so that like maybe it knows that it's having a hard time identifying, like maybe it uses like width and height. Maybe like to determine orientation, right? He's like, oh, I know that like usually they're this way, and so I'm going to like look at the width relative to the height of this thing that I predicted. I know that I'm good at that, but I'm like, I predict rotation by looking at the width and height relative to each other and seeing like which way they're pointing, right? But maybe on square barcodes, it can't use that information anymore. And it knows that it uses that information, and so it knows that it doesn't do a good job here. It could like use that information to predict whether it did a good job or not, and we can use as like our target of like, did you do a good job, as box overlap, right? So we have like, if we predict this, and if this is the box and we predict like this. Ah, fuck. You know, you have like this area of overlap, and then like the total area of the two boxes combined. If you take the like intersection over union, is what they call it, i.e., like black over red areas, um, then that will give you like an approximate like how good is the box, right? And so we did a stream already where we spent a bunch of time figuring out how to do this calculation. I think we actually have it here. Demo, IOU demo, yeah, nice. We have this guy. So we have, you know, IOU is right here in the bottom left, and you can see like as you rotate this thing, the number goes down. If like they're wrong, the number goes down. But if they're like they line up real good, number starts to get pretty good, right? So YOLO said we just try to predict this number, and we use that as like a confidence value for if we like the box or not, right? You could threshold this as like, is our IOU above like 0.7? If so, great. And so we should add a way to predict this. We have the code to calculate IOU. We just need to hook it up to our training labels. So I think what we have right now is we have an area of the code where we heal our training labels to match orientation. So like, you know, you have a barcode like this, and we have said that it's pointing this way, but we also want to accept it if it pointed this way, right? If we predicted this way, those are like, we want those to be equally valid. So what we do is we like, after we do our, like, run the neural network, but before we calculate how wrong we were, we just say like, hey, could you like look at like the line we predicted? And if like, it's like kind of pointing more away from you than towards you, can you just like flip your prediction to like point this way instead? Right? So like if the prediction points kind of like up like this, we'll be like, this is closer, pick that one. You know what I mean? And so we already have like a segment of code that is looking at look at what was predicted and adjust my labels according to that thing. So I think we can just change this like heal orientations thing to, we can just rename this to heal bbox labels. You know what I mean? And then in here, we can just do IOU prediction like we would before. I think we can do it like this. And so I guess we also, in our configuration now, we need a flag to say if we want to predict, if we want to predict IOU. So I guess what we'll do is we will adjust our like box label sizes. You know, where we had box stride here. I think what we do is we say box stride is 6. If label in frame, we say in frame index is equal to box stride, and box stride plus equals 1. This should allow us to kind of like dynamically choose either set of options here, I think. And here we'll say, you know, predict IOU here. And we'll have like IOU index here. And I think we'll say like in frame index is, we'll kind of set them both to 0. Because we'll know that they're not the first ones. And then we can say here, I guess we kind of know. Yeah, we have this. So basically where we were putting a hard-coded 6 in here, we'll look at in frame index. Great. And then we'll have predict IOU here. And if this is true, we will set that to 0. Yeah. Okay, there we go. I think that looks kind of right. I think. And so then we have here box stride is like this, and then we just need to like pass in this predict IOU thing. Okay. Cool. So now in where we call this from barcode gen, we need to like tell the GPU if we are doing that thing. So we're gonna have label in frame, predict IOU like this, bing bang boom. This I feel like is getting kind of hard. So can we do like barcode gen make bars params? It's time. It's time. Oopsies. So this guy's like params, make bars params, great. Yup, 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 yup. Got a lot of params dot shit to be adding, but it's worth, I think. Okay. And this is fine. I'm willing to tank it here. I'm willing to tank it here. Okay. We do the same thing here. Box label size is 6 if I guess like plus int from bool label in frame plus int from bool predict IOU. This is kind of like our box label size here. Bang bang boom. Cool. And then we need to pass in that thing here. Predict IOU. Okay. So what we should see at this point is that what we should see is, hold on, my brain, that we have an extra prediction that is always 0. That's kind of what we're hoping. What the fuck is this? What is that hard coded to? I'll probably like enable backgrounds. Like this. Okay, and then we have predict IOU is self-config data. Maybe this is just like predict IOU here. No, I think label IOU is like maybe what we want. Data label IOU feels right. Okay, and then what's he pissed about? Num images maybe? Okay. What's this pissed about? U1 cannot represent integer value. The fuck? That better? Okay, and then this guy needs the same treatment. So this guy takes a structure now. And it's like CL alloc is this, ran params is this, enable backgrounds is this, num images is this, label in frame is this, predict IOU is label IOU. And then I actually want this to be called label IOU instead. I like that better. Because here in data generation's perspective, you know, he doesn't know about predictions. He only knows about labeling is like the correct terminology there, I think. Okay. And then this guy's mad because we also need label IO here. All right. All right, all right, all right, all right. This guy needs the same treatment. And I think I want to do the same thing here, to be honest. I guess maybe this guy can just take... Like, maybe this guy can just take the parameters, to be honest. Right? This guy can just take, like, make bars params like this. And then he can kind of come in like this as... Like, make bars params is barcode gen, make bars params. Then a lot of this stuff kind of just, like, disappears. Yeah. And then this stuff he can, like, use. This is, like, make bars params. Because that's technically not in there anymore. Here we go. And now this guy's the guy who gets to go crazy. Yeah. Okay. So a lot of this stuff... Okay, here we go. We're getting there. We're getting there. We're getting there. Here we go. Label and frame. Config data. Label and frame. Config data. Label IOU. Boom. Okay. And then what else does this guy take now? It's like barcode generator, params, executor, target, barcode size. Executor, target, barcode, image size here. Okay. Hype. Then we want to just kind of give this guy the same treatment over here. Oh, wait, this was supposed to be, num images here was wrong. Val size is what this is supposed to be, and then this guy down here almost certainly gets like the same parameters, just with train size, I think. I think it's something like that. Something like that. Okay, so now what we should see is that default config still works. Except he's mad because he got a missing field, so oopsies. So we have, I guess what we can do here, that's fine. Label IOU false. And then we just put this in these other guys as well. And then we want to edit experiments star pi. What? How is experiment star.py too many file names? Fuck you. Experiments star pi. Okay. Label IOU. Label IOU. Label IOU. Okay. And so now we should see that, like, how do we want to do this? I guess we want to train this for a second just to make sure that he still works okay with default bbox. Hype. So that's all working correctly. And then can we look at, I guess, something like Experiments 002. Oh my god. I guess we do this. This is easier. Experiments 00. What's like the latest one? Does this one still work as well? Yeah, so both of these guys look like they're like still training okay. Great. And so now we can add like a new experiment here. That's like fourth experiment is, what did we even do? We said like predict IOU, right? So label IOU needs to be true here. And then our network has 8 outputs now. Right? So we can say smelly 4. Okay, so what we should see is that we get like 8 outputs. Instead, he's freaking out because our loss multipliers are wrong again. So here we're like, yo, IOU prediction, let's slap that at like 0.1 as well. To be honest, these should be like lower than rotation, but yeah, I'll just throw a 0 on this one. We're kind of already committed to the 0.1 on the other guy, so fuck it. Okay, so this is training now. He's mad at validation. Yes, so we need to do this. We need to do like the same trick here. If plus int from bool of this plus label in frame. There we go. Okay. So then this is the same trick as U32. Everywhere we have 7 in here, condition to 8. So like we should say like max num predictions here is 8. And we should use that everywhere. Yeah. Okay. So then this should all still work, but these like labels now are a little bit more like variable. So this should be like we have max num predictions of these guys that start with unknown and unknown. If if config data label in frame. Oh shit, we need to predict everything all the time, which is annoying. Like, not predict everything every time. All of our stats need to like have the same keys in them. Which is annoying. This makes this kind of hard. Here's what we'll do. We're just gonna say we have IOU here, and then we're just gonna say debug assert. Like if config data label IOU. Yeah, here's the fix. Don't want to deal with label shit, with label ordering problems. There we go. Solves that problem. Solves that problem for sure. All right. So now we should have something where he is basically learning to always predict 0 for the last thing, right? So here we're like, we have some like XY predictions here, width height predictions here. Can we look at like a different... I just want to be able to like see, yeah, here we go. So we have like XY, width height, rotation, this is if it's in image or not, and then this prediction of IOU is just always 0 right now, right? Because we haven't tried to set that thing yet. So he's 0 by default, which means that we need to make it so that that number is not 0 all the time. So we need to say on heal bounding box labels, he basically just needs to set that shit. Actually, yeah, this is bugged. Which probably, this probably explains why our rotation loss was so fucking bad before, is because this is fucking doing, like, the orientation healing is like doing the wrong thing. That's funny. So we should probably commit that part separately. So let's do this. Git add-u. This is whip predict IOU stuff. And what we need to do is anything that has like a ×6 in here is like really fucked. Yeah. So can we just like search 6 here? So fix me wrong. 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 Cool. Cool. So here, can we just pass in like box stride here? Like this. And then here we say like 0 to 4 is equal to 5, like I is less than box stride, I++ or something. Thread out, I is thread in I. Just tune in. What are the features you train MLP on? I don't even know what that means. I'm an idiot. I don't know what we're fucking talking about. Okay, so this one's fixed. Probably, maybe we should probably check these. Where else does it say fix me wrong? Here we go. So this guy also needs box stride here. Who gets box stride, or like inbox stride, I guess. Here, this is input box stride. And then here we do the same fucking shit where it's like 4, I think we don't need to, this is creating a like XY with height rotation box. So he doesn't look at the rest of the labels. We should call it in label stride probably. In label stride. Yeah, that's a better name for this. Labels in like label stride. Yep. Boom. 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 Easy. What goes into the input neurons or your multi-layer perceptron? Like images of barcodes. Hold on, we can probably show this in a second. Like images of made-up barcodes, I should say. He's pissed. We fucked something up. Oh, it's because this is not in frame anymore. We called this something else. Yeah, that's why. Box strap, fuck. Yeah, I do like the name label stride everywhere here better, actually. Now can we fucking show you? This. Well, there's like two sets of data for 2 networks, but like basically something like this. Something like this. Backgrounds are supposed to be variable and stuff, but like for now they're not. Or sorry, they're not in this visualization right this second, but something like that. Something like that. They'll have to get better eventually, but later. You know, one thing at a time. One thing at a time. They need to represent real life data a little better. Okay, so this should, we need to like be careful about this. Can we do this? Git commit -m, fix up label stride shit, and then what we should do is we should rebase and pull in that stuff where it makes sense. So I think it's here, add prediction for box if box and frame. I think this is where the beginnings of that thing should go. So cherry pick this guy, merge tool, and let's just kind of just see what falls over here. So we want probably what was in head, to be honest. And I think that the only major change here is that we called box stride label stride, I think. Let's just like double check here. So here we have hard-coded 1, 2, 3, 4, 5. This is just in if should render code because this didn't exist yet. Okay. But otherwise it's the same, right? And then this has label in frame, great, but no label IOU because that didn't exist yet. Yeah, okay. So I think the only thing is just we renamed it to label stride, which I do prefer. So let's do that. And then here, this is shit that doesn't exist yet. So we just take all this and we just take anything that says box stride here, and this is label stride. Bing, bang, boom, 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 boom. Okay. Any other conflicts? Nope. So does this like compile and run? Yep. Okay, cool. Cool. So I guess this is a cherry pick continue, and we'll say, shouldn't there be more here? We'll see. So what did this do? We changed box stride to label stride. Great. We added a fix me wrong here. We just didn't fix that part yet. That's funny. But then we have some 6s turned to label stride. And then this is also still fucking wrong. Like, this isn't finished. Hold on. Hold on. Hold on. We're not finished, but we gotta figure this out. Hold on. Box stride, label stride. All right. Oh, what a disaster. We take everything the way it was, and then we search replace box stride to label stride again. How dare I do this to myself? Okay. Okay, hold on. We're still not done fixing it. Learning from raw pixels is part of the challenge, right? So a feature extractor like in barcode RGBA out list of bar widths would not be allowed. What do you mean wouldn't be allowed? If the network can learn it, it can learn it. That's like a thing that we could try for sure. I mean, like I guess you would have stuff in between, but like kind of like that's like a thing you could add as one of your outputs. Okay, wait, we weren't done. This thing doesn't fucking run right now. It's surprising that image gen does, but I guess a bunch of other stuff won't, right? Like, so it's like scanner won't work anymore. Oh, for lots of reasons, fuck. Smelly won't work. Right, because he does work. That's confusing. we have to get a little bit. So this, if I put in like label stride here, then it should stop working. Yeah, this needs label stride because it changes. But everything else in here is fair game. Now running Smelly should fail because he'll like fail to heal the orientations, I think. Yeah, there we go. So now we need to like go to all of the places where we added label stride and fix them, and I guess make sure that we're calling these from the right spots as well. Heal, so heal orientations. This is called something else now. Barcode gen. Oh yeah, we called it like labels. Heal B-box labels, here we go. And I guess here we need to know, I think really what we should do here is on initialization, we should write down the box stride. I think that makes more sense. Maybe not. Maybe. No, that's fine. For now, we'll pass in here, label in frame and label IOU. And then we'll make a function here that says like, box label len here that takes in label in frame and label IOU and returns a U32, and he just says like return that dumb shit. So it's like as U32.6 plus int from bool label in frame plus int from bool label IOU, easy. So we have this guy's like, oh, he actually can infer this from the label length. Oh, so he actually doesn't need this. He can just throw in a like uint here as like label dims get 0. And here, I guess that means that we're kind of inferring. Yeah, that's probably fine. Probably. Sure. Sure. Okay, so Smelly should work now. And we're kind of expecting that our like rotation stuff should get fixed by this, I think. You don't need a network for that. Yeah, it's just harder than you think. It's just like a hard problem. Just like look at the egg carton. Like it's just, this is like a complex signal processing problem, I think. Right? There's a lot of like, there's also like a lot of other degenerate cases, like an aluminum can, right? I think that there's just like, this is like not trivial. I think you're right that you don't really need a neural network for it. But I think that it's harder for me to do it by hand than to make a neural network to do it. And it's a good excuse to make a neural network training framework. It's kind of like a fun problem. But yeah, you could get something that's like scans okay in like, 100 lines of code. But we'll get there. Okay. So what the fuck are we doing? We're trying to like update this heal bounding box labels thing. Well, I guess we have two things that we have to do here. One is that we have to fix the stuff that was broken before in the past commits, and then we have to update the bounding box labels. So what we should be able to do here, making sure data layout is correct. If we take our default config and we make this like a ensure working config, we should be able to turn on label in frame and turn on label IOU, right? And we should be able to come back to the loss multipliers down here and just say, yo, those guys, irrelevant. Don't fucking even care about those. Let them be whatever the fuck you want. And we should see a network that performs approximately the same between default bbox and ensure working. So let's do this test. Okay. Can we do like experiments like working is working tests or something? Let's put this here. Okay, so what we should be able to do is we run that like timeout shit on experiments is working. Is working. And he's gonna get mad that like experiments is working out doesn't exist yet, but we run this, he's mad because file not found on something. What the fuck? Oh. There we go. Okay, so we have 15 seconds of training 1, 15 seconds of training 2. We don't need to train for that long. We just have to make sure that like the data is not like absolute fucking hot fucking ass garbage. So if we train for 15 seconds and the training curves look approximately the same here, then we're chilling. But if like rotation or something looks really wrong, then we fucked something up. But we'll see. So what is this? Experiments is working out star log CSV. Nice. Okay, good. So if we look at overall loss, nice. These curves are like lined up, right? So it means that we didn't like heavily fuck up the data like we were before. So let's I'll do like the git rearranging later. To split, we'll say we call this fix broken labels. Okay, so now we're back to the problem that we were trying to fix a second ago, which is that IOU predictions are always 0 right now. We aren't healing them yet. So that should go in here where we said heal orientations. This guy is now not just healing orientations. He is also doing like calc IOU. So we have something that does that already. IOUCL here. We have calc IOU from this stuff. We have a bunch of A boxes, a bunch of B boxes, a bunch of outputs, and N. So what we should be able to do is we should be able to make like a function that we can kind of call from our heal kernel that just takes in like, does he like parse this stuff to boxes? Yeah, he does. Right, so we can do struct box A, struct box B. So given these two boxes of form XY width height rotation, can you return me my IOU? And we should be able to kind of take most of this stuff and just kind of slide it over here. And then instead of doing this, we just like return here. And then calc IOU, the function that we were using before, is going to okay. Can we change this? So our boxes are only storing points here. Here's what we'll do. We'll just fix this. Box area. So this is like box top left minus box top right. This is like fucking stupid, but we're storing our boxes as like a list of points. So like extracting their width and height should be relatively easy. So this, we just want like the length of this thing. Distance, I think, is the function here. I think that this kind of fixes some problems here. So now we can just be like box area A box, and box area B box. Okay. So as this stands, we should be able to like run our unit tests. Ah, fuck. Whatever. And the IOU calculation stuff should still work with these changes. He's fucking pissed off. Distance doesn't... Oh. Sure. Distance requires 2 params, I guess. Okay. He's still not happy because I forgot some semicolons. Classic. Classic. Still not compiling because box area from data wrapper doesn't exist area from anymore. Oh, so I didn't finish this. This guy is supposed to call all of this stuff is now just like calc IOU inner A box B box. And then we should, if this compiles and runs and passes unit tests, we should have a function that we can call from our like label healing stuff. Nice. Okay. So now we have this like calc IOU inner function that we can call from here. Calc IOU inner, and we just have to like make the boxes, right? So we're gonna have like we should be able to just kind of struct box A box is here's what we'll do. Oh, it's so not trivial. So box from data repper here. We need to call this with like non-global float star. Oh. Can you compile this like this? Does that work? Or does he say that like this thing needs to know which memory bank he's pulling from? He probably does, right? Oh, he does. That is allowed. Okay, so that means that here I can just say like, I should be able to call box from data repper with like, something that's like common repper A, common repper B or something, where we have like float star common repper A and like local memory. Do we have like, I guess we just have this float. We have 5 floats for common repper A. And this is going to be thread label 0, 1. We have square root of width and height, so we need to convert these into not square roots by squaring them. And then our rotation, we need to call atan2 of 4 and 5. 5, 4. It's y over x. Okay? Cool. So this is common repper A. This is common repper B, which is not from the label, but from the prediction. Everywhere that says label here, we just do prediction. And then we should be able to be like this. So this is struct box A and box B. And then we should be able to call calc IOU inner. Is calc IOU inner box A box B. I think that this is right. And then I guess we can probably get a little tricky here where we say like a uint IOU index is label stride -1. I think that might do it. Might not, but it might. So I think we need to make sure that this guy has access to the IOU code. So we have like math executor IOU program content. Just like compile this all together. Put a big soup of shit. And there's like a non-zero chance that that works. He's mad because I didn't close the A10 Yeah, fine. You're right. You're right. Fine. I'll fucking call the functions I'm trying to call. Okay? If you're gonna be like that. Okay, so what we should see here is that at the output here, he is now predicting a number for the last digit, for the last output here. So 0, 1, 2, or sorry, 1, 2, 3, 4, 5, 6, 7, 8. So he is predicting a thing there. And we could try to start looking for if it's correct. But what we can do instead probably is make it so that we export that thing as a validation statistic. Which I think that we are already doing. Kind of like by mistake. Let's see. So we have IOU loss here, starts up here, and he does like get lower over time. So that's good. That is good. We have everything we need, I think. And so assuming that we can get something that doesn't like training crash like we did just now, we have enough stuff to run these experiments, I think. So we set up for checking if things are in frame. We set up for fully removing some barcodes from some of our training, and then we added another output for IOU prediction. I guess we should check. Wait, we've probably fucked something up here. Actually, I think our baseline is still probably broken, right? I bet you we fucked something up there because we don't have in our heal orientations thing. We didn't check if we are predicting IOU. So here he needs to say predict IOU here. And he should only do this part if predict IOU is the only time we should do all this like IOU shit. Right? Otherwise, we don't want to add him there. Yeah, okay. Okay, so we need to go back to... Sorry. What are we trying to do here? We need to go to who calls this? Barcode gen. Heal orientations. And here he has predict IOU comes in here. Or like label IOU as a bool. And this needs to come in here. Cool. And then we should be looking at main. When he says heal bbox labels, he needs to throw the config data label IOU in here. Cool. So this should compile. Great. And then we need to do is we need to check that our loss curves don't like we should compare before all of our changes and after all of our changes on the baseline config to make sure that loss isn't getting fucked. That's what we should be doing. Because otherwise we'll draw wrong conclusions from all this. So this is like git commit -m IOU prediction cleanup. We also haven't checked that the IOU labels are like reasonable, but we'll get there. We'll get there. So I want to go back to origin master. And I want to call I want to like run 15 seconds of training on just like our default config here. Right? Just let them run for like 15 seconds. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, right? Chill. Move training output to like pre-changes. And then I want to go up to whip and basically just do the same shit again. So be like, give them some time. 1, 2, 3, 4, 5, 6, 7, 8, 13, 14, 15. Right? And so if all of the code is right, these guys should look very similar. I think that our graphing thing is going to get mad if they don't have the same sets of keys. Where I think he's actually maybe okay. He's only showing one of these guys. Oh. No, wait, this is good. No, this is actually working. Wait. Look at this. Wait, that's awesome. So these training curves are not only almost the same, they are fucking exactly the same. Which is really fucking good. Right? That's actually quite surprising. But it means that like the new code, unless I didn't run zig builds when between checkouts, is like producing the same results. We have zig build in this command, and then we did checkout whip here. So we did move from BBF to 8C3. Yeah, so I think that we did the right thing. Explain to my uneducated brain. Yeah, so I wanted to make sure that we modified the code a bit to be like, we have these like new features that we're adding, right? And there's a chance that by changing the code at all, we like accidentally fucked up the like baseline case that we're trying to test against. And so like that test was like a quick sanity check to make sure that at least the baseline case is still the same. So when we like generate training curves later to compare, we know at the very least like the baseline case is correct, and we can like compare everything to that. The other thing I wasn't 100% sure about is I was worried that this like in-frame prediction stuff started to like nuke it started to, it was going to, how do I say this? I was worried that like the data format is not correctly handled everywhere. So this ensure working test here, it asks for labels on these new labels that we added, but it sets their like contribution to the output to 0. So we should also see that this ensure working thing, I'm hoping, what do we call it? Was it is working? So if we do the same test here where we run the baseline and is working together, we should see that those two training curves are very similar too, which means that at least the data format is like approximately correct. And I think between those two things, we have enough information to prove to ourselves that when we run these tests tonight for like longer term, that they will produce reasonable results. I think. Yeah. So this test is, again, we are making labels for these things. We are just setting the amount of contribution to training to 0. Is working. Okay. So if we look at overall loss, these are tracking very closely, which is indicating that we're correct, right? And then we do see here that like our overall error is higher, but that makes sense because our error for IOU prediction and in frame prediction are just like fucked. They're like, because they're not learning at all. Okay, cool. Happy with that. That is a good place to end it. It is 4 o'clock. Thank you for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 Pacific time to 4 o'clock Pacific time. We're working on this like barcode scanner thing right now, but there's other stuff, in the backlog. So if you're watching live, there's a YouTube link in the description. There's a lot of stuff in there if you want to check it out. We've been doing this for a couple of years now, and so there's a lot of just like rabbit holing on random shit. If you can't watch live all the time, also most feature development goes on the YouTube. We kind of like segment the stream into like 2 segments. One is like feature development. I can post this on YouTube and like the algorithm will push it, whatever type content, or at least I hope the algorithm, I think it's possible that the algorithm would push it. But there's stuff that like doesn't really fit into that category. And like also I want to stream for more than like 2 hours a day. And so like everything, it's too much content to put on the YouTube all the time. And so stuff that doesn't go up there goes on Patreon or on YouTube members, or if you sub on Twitch, you can see them on the Twitch VODs. And like that's gonna be stuff like today we were doing a comparison with PyTorch. So we like took our network, we ported it to PyTorch, and we were just like, how much slower are we compared to that, right? So if you want access to VODs of the stuff I don't post, please consider supporting on whatever platform makes sense, Patreon, YouTube, members, or Twitch. And in return, you get those VODs, plus the knowledge that, you're helping the stream stay alive. I think that's all the plugging we gotta do. YouTube, peace out, and Twitch, let's find someone to raid.